AP 120, Chapter 11. Topics: Thyroid, Parathyroid, and Adrenal glands. So, the thyroid gland, one hormone the thyroid gland produces is the thyroid hormones. Actually, technically, it's two different hormones, but we're just going to say collectively thyroid hormone. And the release of the thyroid hormone is controlled by the pituitary gland, the anterior pituitary gland. As we know, it releases the thyroid stimulating hormone, stimulating the thyroid gland to produce the thyroid hormone. The function of the thyroid hormone is to regulate overall energy metabolism. So it's basically sort of sets how hot our body systems run. So people who produce a lot of it can eat like a ton of food and never gain weight. People who only produce a smaller amount might have issues with weight control. So it increases the rate cells release energy from carbs, speeds up the burning of carbs to produce energy. It enhances protein synthesis, so more protein products get produced. It also stimulates the breakdown and use of lipids, of fats. That, of course, determines the basal metabolic rate, overall speed of the body systems. There's a second hormone that the thyroid gland produces. This is called calcitonin. Calcitonin is released when calcium levels in the blood are too high. So blood calcium levels rise too much. This triggers the thyroid gland to release calcitonin. Calcitonin goes into the bloodstream and ends up stimulating the osteoblasts in bone tissue. As you remember, osteoblasts build up the organic matrix of the bone tissue, and then that tissue calcifies, pulling calcium and phosphate out of the bloodstream. The calcitonin also inhibits the osteoclasts. As I'm sure you remember, the osteoclasts normally break down the organic matrix of bones, causing the release of calcium and phosphate into the bloodstream. So causes more bone tissue to be produced and less to be destroyed, thereby pulling calcium and phosphate out of the bloodstream. Also, calcitonin goes to the kidneys, and there it causes the kidneys to increase the excretion of calcium and phosphates in the urine. So calcitonin causes urine levels to include additional calcium and phosphate ions, all to lower blood calcium levels. Then we have the parathyroid glands. These are small glands located on the posterior side of the thyroid gland, and they release their hormone, the parathyroid hormone, when calcium levels in the blood are too low. So calcium levels in the blood get too low. Parathyroid glands detect this. They produce the parathyroid hormone. That hormone then stimulates the osteoclasts in bone tissue. So the osteoclasts break down more bone tissue, releasing more calcium and phosphate into the bloodstream, and this will increase the blood calcium levels in the blood. So stimulating osteoclasts will increase blood calcium levels. Parathyroid hormone also goes to the kidneys. And in the kidneys, it stimulates the kidneys to conserve calcium ions. So less calcium is released in urine. And it also signals the kidneys to produce and release the active form of vitamin D. Vitamin D will then go to the small intestines and increase absorption of calcium from the foods we eat. So we release more calcium from the bones. We conserve calcium from the urine, and we increase the amount of calcium absorbed in the intestines. So, parathyroid glands detect low levels of calcium in the bloodstream. They release parathyroid hormone. It goes into the bloodstream and reaches the bones, causing osteoclasts to break up bone tissue, releasing calcium into the bloodstream. Also goes to the kidneys, causing kidneys to conserve calcium ions, so less calcium in the blood, less calcium in urine. Also causes the kidneys to activate and release vitamin D, goes to the small intestines, increasing the absorption of calcium. So all these acting to raise calcium levels, and when they get to the ideal levels, This is the negative feedback signal to the parathyroid glands to stop producing the hormone. So again, calcium levels controlled by two hormones, calcitonin from the thyroid gland and parathyroid hormone from the parathyroid glands. All right, the adrenal glands. The adrenal glands are structures that are directly superior to the kidneys. So here's the kidneys, the adrenal glands are above them. There are basically two glands within the adrenal glands. You have the adrenal medulla and the adrenal cortex. The adrenal medulla is the deeper tissue of the adrenal gland, and the adrenal medulla secretes the hormones epinephrine and norepinephrine. So two hormones, epinephrine and norepinephrine. These are commonly called adrenaline, and they are used and released at times of stress, at times when our body wants to trigger the fight or flight responses of the body. So when you are scared or angry and may need to fight or run, then it causes various effects from the release of adrenaline, faster heart rate, faster breathing, increased blood flow to muscle tissue, suppression of the gastrointestinal tract, suppression of salivation, various responses like that. And these hormones, epinephrine and norepinephrine, are released via neural signals. So neurons stretching from the hypothalamus will cause the release of epinephrine and norepinephrine. And we have the adrenal cortex, which is the superficial tissues of the adrenal gland. The adrenal cortex produces over 30 different kinds of steroid hormones. So we're going to break them up into three groups. Group 1 is the aldosterones. Aldosterones are mineralocorticoids, so they are affecting the level of electrolytes in the bloodstream. So when aldosterone is released from the adrenal cortex, it goes to the kidneys, causing the kidneys to conserve sodium ions and also water. So kidneys are now returning sodium ions to the bloodstream, and as a consequence, water is also returning to the bloodstream, leading to more concentrated urine. And the kidneys also start to excrete more potassium ions. But the big effect is conserving sodium ions and therefore conserving water, making the urine more concentrated. This is in response to decreased blood volume and or blood pressure. So again, conserving water, preventing it from being released in urine will help decrease the loss of blood volume. Then there's cortisol. Cortisol falls in the glucocorticoid category. Gluco for glucose. So cortisol influences the metabolism in response to stress. So when the body is under stress, cortisol is released and does a lot of things. It decreases protein synthesis, so less proteins are produced. It increases the release of fatty acids. Fatty acids can then be used as an energy source. And it increases liver production of glucose, but not just any production of glucose, but glucose from non-carbohydrate sources. So now the liver is breaking down, say, amino acids to produce glucose. So it makes sense now. Decreased protein synthesis, you need to decrease that if you're using up amino acids to make glucose. So higher centers of the brain signal the hypothalamus to release the corticus-releasing hormone, goes to the anterior pituitary gland. It sends out its adrenocorticotropic hormone, which then goes to the bloodstream, goes to the adrenal cortex, causes the adrenal cortex to release cortisol. Cortisol inhibits protein synthesis. It then promotes fatty acid release, great energy source, and stimulates glucose formation from non-carbohydrate sources. And then the levels of cortisol in the bloodstream act as the negative inhibitor, telling the hypothalamus and the anterior pituitary gland that they don't have to produce hormones to trigger cortisol production. All right, the third category are adrenal sex hormones. Adrenal sex hormones are chemically related to estrogen and testosterone, and they supplement those released by the gonads. Also, back when we were embryos, they were a big source of production of sex hormones. So they help to stimulate the development of reproductive organs in embryos. And that is it for this part of Chapter 11.